Hey there, my name is Jesse Pence. Welcome to my series on React Server Components. Let's go ahead and get started. On December 21st, 2020, the React team released a short statement along with an hour-long video. In the video description, they said 2020 has been a long year. As it comes to an end, we wanted to share a special holiday update on our research into zero bundle size React Server components. The demo is available now wherever you want to play with it during the holiday or when work picks back up in the new year. And as you can see, the concepts were already pretty fully formed, with zero effect on bundle size, access to the backend directly, automatic client code splitting, use as much or as little as you like, with a server mental model and modern UX. And you can see the tree that they had here illustrating the idea of interleaving the client and server components within the same root tree. And over here we have Lauren Tan going through the React Notes app, where we already had, the serialization format was already starting to take place. It's changed a bit since then, but a lot of things are pretty similar to the way they are now. But this was December 21st, 2020. So what's been going on? So this is just chapter 1 out of 15 chapters. We'll get to what we're going to be talking about in each video in just a moment, but first let's just do a quick plan for this video, where I'm going to talk about who I am and what you should know, the history of React, where we are with React Server Components now, and then a look ahead. And then over here, who am I? Why am I doing this? My name's Jesse Pence. I'm a relatively new programmer. I really just picked up web development last year after I quit drinking. I was a bartender for most of my life. I'm not an expert. I'm just really, really obsessed. I found web dev and I fell in love, and just React Server Components has been a really interesting challenge for me to understand. As you can see, this says 2 months ago, but it's actually been a while since I even took the screenshot. I think it was about 3 or 4 months ago. I made a few other videos where I tried to make React Server Components from scratch. I followed along with Dan Abramov's article, and then I tried to complete the challenges that he had at the end. And I thought that I had a pretty good understanding of how everything worked, but I didn't really understand everything. So I have been down a rabbit hole. And I'm going to try to explain it all to you. And really, you don't need to know much. And I'm sorry, I'm going to have to move around a bit because I didn't plan this out very well. You don't need to know much. Just have some basic JavaScript understanding. This isn't where you should learn React in the first place, so you should probably understand some React fundamentals. But you're not going to need to know that much because we're going to really break everything down. So in the end, you won't need to understand the React reconciliation algorithm, but I have good links for that if that's something that you want to do. Mark Erickson has a great article. There's a couple other great articles. I'm going to have a whole long list of articles down in the video description, and then I'll also have my articles are just insane link rabbit holes where every 10th word is a link. So if there's something you want to learn more about, just go and read in the article. These are just going to be more summaries than anything else in these videos, because the articles are going to be 3,000 to 10,000 words long. The articles are no joke, so the idea of these videos is just to make everything more approachable. And so let's, if you think I misspoke, I probably did. I'm not a good public speaker. Just refer to the articles as the central source of truth. I will say things wrong sometimes. It's just what I do. I'm sorry. And so really quickly before we move into everything, I just wanted to say that if you do notice a mistake, please do not hesitate to point it out down in the comments down below on YouTube or in the comment section on my blog. This is all supposed to be a learning exercise. So I would really love it if we could all learn together. And if I have anything wrong, it's not because I'm trying to mislead anybody. I'm not trying to sell anyone anything. I'm just trying to learn. And I'm trying to share what I've learned with you guys. So if I've made any mistakes, please do not hesitate to point it out in the comment section or on my blog. Please. Okay, so let's go ahead and move into the history of server-side rendering in React. And as we'll see, it's been a pretty long storied history. All the stuff we were going to talk about has been before server components in 2020. In fact, here's Jordan Walk at JSConf in 2013. This is May 29th through the 31st in 2013. And this is one of the first times the world ever sees React. He didn't get the best response here, but there were a bunch of really good quotes in there, like this part where he says, "So you could, in theory, render the markup on the server and then attach all the event handlers and instantiate all the backing views on the client. Two completely separate machines." And so this was wild at the time. It's something that we know as hydration now, and it's a bit old hat. People kind of think, oh, hydration, who cares? Well, we have to remember at this time, people were creating like a Backbone app and then an entire Rails app at the same time so that they could cover their SEO and cover their bases for people who didn't have like the JavaScript enabled. So they would have to completely mirror their routes in two entirely separate apps. And so this idea that you could just render the markup and then instantiate and attach all the event handlers, like that was a wild concept at the time. And so render to string has been around in some form since around July of that year. At the first, it was called render component to string, and then in October 28th, it was renamed. At some point, it was asynchronous, and then later it became synchronous. And so the idea is, I'm just going to read this down here. You probably can't see it. It renders a React element to its initial HTML. React will return an HTML string, and you can use this method to generate HTML on the server and send the markup down on the initial request for faster page loads and to allow search engines to crawl your pages for SEO purposes. Very explicit about what the purpose of server-side rendering was. Right there, you can see. If you call React DOM.hydrate root on a node that already has the server-rendered markup, React will preserve it and only attach event handlers, allowing you to have a very performant first load experience. So we have React.renderToString, which has been available since near the very beginning of React, and it converts React element trees into literal strings of HTML, literal letters and characters just like you typed it out. But the problem is that's only a visual representation of the app's current state. So it must be reconstructed because React uses this virtual DOM paradigm. So it needs to call React.createElement basically on each of these individual HTML tags as it moves through the page and figures out the way that the React element tree should be constructed from it. And so the problem is that the React app is not interactive until that process is completed. So why do we go through all of this effort for server-side rendering? Well, as React already mentioned a lot of it over here in terms of faster page loads and to allow search engines to crawl your pages for SEO purposes. And SEO is really what it all boils down to. You need people to be able to find your website, to be able to sell your products or whatever. And Google search results are based off of this core ranking system, which uses these core web vitals to reward content that, quote, provides a good page experience across many aspects. So we have these things like time to first byte and first contentful paint and last contentful paint and time to interactive. This is a fantastic talk from Ryan Florence. It's called When to Fetch Remixing React Router from Reactathon 2022, where he talks about a lot of the issues that React apps face when it comes to trying to maximize their core web vitals, because heavy JavaScript tools like React naturally weigh heavily against them. Like it's like they've been trying to give you all of these tools like React.Suspense and React.Lazy, which has helped for code splitting, but unfortunately Suspense for data fetching requires server components to work correctly. So unfortunately we've had all of these empty shell apps full of loading spinners because people delay their loading until they get to the client side. The only way to avoid that is to use a meta framework or something like Next.js, where we have this double data problem. And so the idea of a double data problem is that we have this two-step rendering process across the server and the client, where the server creates a string representation and then the client hydrates it into a virtual DOM. And it requires sending all the necessary JavaScript to the client, and it results in duplicate work on both the server and the client. And then plus you need a router. That's the key, is that you don't want to lose all of this stuff after the user clicks on a link. You want everything to persist across each page load. So you end up having to send the exact same data in the markup and in the JSON as well. And so look at this. We have this. I don't mean to pick on this Next.js template, but this is a problem across a lot of different frameworks. It's not just React, but I just picked a random Next.js template because I knew I would find this. It's something that is common across all meta frameworks, where we have this dynamic routing and static generation by JJ Casper, blah, 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 blah. And then down here we have dynamic routing and static generation by J.J. Casper. And we have the HTML markup with all of the data. And then we have this JSON representation of all of the data sent as a script tag as well to help with the hydration process and help with the Next.js client-side router so that it knows what it needs to load for that page. All of this data was loaded on the server, and that helped with the initial page load, etc. But the problem is, like I said, you don't want to lose all of this data whenever the user clicks on a link or anything else. So we also need to send all of the other data as well. The only thing you can do is a little bit of code splitting with like React.lazy, but we also have this other issue with server-side rendering and hydration in React, which is something called the uncanny valley. To fully understand what this means, let's go into one of the React Server Components from Scratch demos that I made in response to Dan Abramov's long, wonderful article that he made. So this is near the end where I was trying to institute client components without using React Server DOM Webpack. So without using any of the tools that React gives you for server components. So I did all kinds of crazy stuff. There were like 10 demos near the end. In this version of a demo, I was rendering each client component to string individually and then hydrating each of them individually on the client side. It's like one of the worst ways you could probably do it. And so to see why this is an issue, I slowed it down to slow 3G network here, right? So I'm going to refresh this and then I'm going to click on this button, which is a client component. So we are going to refresh and I'm clicking on it as fast as I can. Click, 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 click. But until all of that JavaScript finishes downloading and it hydrates the button with the event listener, we are in this uncanny valley where the button is not responsive to user input. But as you can see in my naive implementation, it's about as bad as it can be for somebody with a slow network, where they're in this uncanny valley for way too long. Nothing is responsive, and it's a very frustrating user experience. So let's go back in here and you can see that it's the period where UI elements are unresponsive that occurs before HTML is fully hydrated. It's a challenge that is unique to SSR with modern frameworks, and it can affect the user experience negatively. And there's some really fantastic articles from people like Adi Asmani has this really fantastic series that he does called The Cost of JavaScript, where I got this graphic that you can see. You can see the initial request, the HTML arrives, the view is painted, and until the JS is parsed and evaluated, we are in the uncanny valley. And so you can read the article if you want to learn more about that. But first, we're going to talk about how streaming SSR, which is codenamed Fizz with the React core team, we're going to talk about how that has helped with some of these issues. It was originally released with React 16.0 in 2017 and is part of React's first-party solution to SSR challenges, along with the others I've already talked about, like Suspense and Lazy, and it's what laid the groundwork for React server components. So this is another Adi Asmani article with Lydia Halley, fantastic. They both create great stuff. And this is a streaming SSR article from their design patterns series. So the main thing you should get from this graphic is that the first byte arrives sooner, which allows for the first meaningful paint to arrive sooner, which improves your core web vitals. This does not help with things like the double data problem or the uncanny valley, but it does improve your core web vitals, and we'll see that the React Server Components architecture, codenamed Flight, was all built upon this Fizz work that they achieved beforehand. And they originally released this in 2017, but then you'll see that they go hand in hand together. The React Server Components architecture requires this Fizz architecture to work correctly. So first, let's talk about what are React Server Components. So there's this fantastic interview released with Sebastian Mark Beige and Andrew Clark, where Andrew Clark said that in a lot of ways, Server Components is Suspense for data fetching. That's what that is. We're not calling it that anymore, but that is our first class. Like, this is the solution we think for the best way to compose data requirements into your app. And so the whole thing was that they had been calling something Suspense for data fetching for a long time after they released Suspense in 2017. And then they kind of just intertwined that with what server components ended up becoming. And so that tells you a lot right there, right? Suspense for data fetching. But there's a lot more to it than just that. But that kind of gets you in the right mindset. So first off, the most important thing is that React server components do not produce HTML. Instead, they take your React elements and then they serialize them into this JSON-ish format, kind of like indie JSON, kind of like new line delimited JSON, but it has these little keys that it uses to know exactly how it was serialized on the server and then how to deserialize it on the client. But the thing is, in order to properly serialize anything over the wire, it needs to be stateless. It needs to be side effect free. It needs to be idempotent. And you need to be able to know that when you call this render function for this server component, you're going to get the exact same thing every time. So what does that mean? You can't have any use state or use effect. So unlike traditional server-side rendering, where you were just producing a visual representation of something that would eventually be fully dynamic, React server components are supposed to be completely static by design. Does that mean that they can't be dynamic or interactive? Not necessarily, and we'll get to that in a moment. But first off, I want to point out this Ryan Carniato quote really quickly. I'm not going to read the whole thing, but you have the same benefits of partial hydration with reduced component code size, the removal of duplicate data, and not giving up maintaining client-side state on navigation. And there's some caveats to that he's found out since he wrote this in 2022, but still, very good summary, and it's a great article you should read. So let's keep moving and start talking about some of these benefits. First, let's talk about bundle size, which is one of the things that they promoted the most when they first introduced RSCs. Remember that first announcement was called Introducing Zero Bundle Size React Server Components, where they had this graphic where each of these tannish ones were supposed to be server components, each of the bluish ones were client components, and as you can see, the idea is that the server components don't require client-side JavaScript. The less JavaScript you send, the better the performance of your app, and the server-side bundle size doesn't matter nearly as much as what you're sending to the client. And you can also do fun things like make database calls directly from your server components. And that's another one of the major benefits of this architecture is that it maintains React's unidirectional data flow. Because otherwise, whenever you're using things like get server-side props or whatever in Next.js, you would have this whole other part where you would define your data fetching and then bring that into your component with the props or whatever. But here, you can just put it right in the middle of your component function. Right there, I'm using this get data function, which uses an API key. And so that would be a big no-no with the old architecture of sending over something to the client with the API key in it. You're like immediately giving hackers your secrets. It wouldn't even be that hard to get. But the thing is, this gets serialized into an RSC payload for secure and efficient data transfer. And you can see this number, colon, and then inside of the array right here, we're going to have this symbol, the $sign. This is for a React element, and it's an H1, because you can see up here I call react.createElement with the H1, and then with the greeting. So the function gets called, and all we can see in the children is the hello world. The get data, the API key, all of that happened on the server, and you get a serialized representation of that sent to the client. And so then it goes even further when you add server actions, because these are remote procedural calls that can give you fresh server components, and it adds dynamic capabilities. So like recently there was a Sam Selikov talk where he had the SQL template tag literal that made everybody lose their minds. It's the same idea like with here, like where they showed this in 13.4, where they're just using something like Prisma to do like a db.post.update, and then you call validate tag, and then you're going to get back a fresh server component for whatever that tag represents. And so with that, they're showing it down here that it represents a fetch call. So you can empty the cache that is represented by that tag whenever you call this revalidate tag function. We'll get more into that later, don't worry. So let's keep moving for right now and talk about RSC and SSR together forever. And so as you can see, RSC can be paired with traditional SSR. You still get the same benefits of SEO, increased SEO from having the server rendered representation, a better initial load. You're not limited to a single RSC server either. You can see that in the official test fixtures of Flight, which as we said was the RSC code name. Remember, Fizz is the streaming code name. And so here we have global.js and region.js. And the idea is that global.js is the SSR server, and it takes the representations brought to it by the region.js, which is on edge servers around the world. And so you could have your database calls in region.js. So especially whenever you want to update the information and mutate data, you can have the database close to the user, and it's not going to have to wait for as long as if it were to go to the single global server. But you would have the central node server, assumedly, which would be controlling all of the RSC servers on the edge. And so they can work together very well, actually. And so let's keep going and talk about the current RSC landscape. So only Next.js? Well, we have this great Dan Abramov quote here. From the React perspective, when we put on our React hats, even people who work at Vercel, their goal is to prove out the paradigm, figure out how the pieces fit, and figure out how to make React better. On the one hand, I get a lot of the criticisms of Vercel. On the other hand, it just gets under my skin, Dan Abramov's skin, when people say that Vercel tells the React team what to do, when actually it's more complicated. The reality is that Vercel has invested years into building out our vision. And somebody else on stage said that React tells the Vercel team what to do, but Dan Abramov said it's more complicated than that. The reality is that Vercel has invested years into building out our vision. So think about that. The Next.js app router just had its first birthday. They've had server action since May 4th of this year, so at this point that's over 6 months. Why haven't other frameworks adopted RSCs yet? So it's complex. This stuff is hard. These APIs are rapidly evolving. The React core team members, there are some of them that work at Vercel, sure, some of the most important ones, but all this code is open source. You can find all of this stuff on the React GitHub and on the Vercel GitHub. I will say a lot of the discussion is private now, which is unfortunate, but all of the code that for the current representations of RSCs, all of that stuff is available in the GitHub. And the rapid prototyping in Next.js helps hone these experimental new features where they're not exactly sure how to work it. And to show how complex it is, I put up this famous chart that Vercel released talking about the Next.js caching layers, because you have these 4 or 5 different caches, it's 4 caches all working together. It's silly. So let's talk about, is this a rigged game for Vercel? Is this rigged in benefit of Vercel just because some of the React core team members worked there? And so I have these like Dan Abramov Twitter posts here where he said, frameworks provide a unique opportunity to incubate these kinds of features before they make it into React as settled architectural pieces. For example, Hydrogen was the first framework to try server components when they were still in a raw state with many gaps and unknowns. The initial proposal for server components used file extensions like .client.js, and the folks at Hydrogen gave us rough but fair feedback. This is not usable. It's too annoying to deal with in practice. We had to go back to the drawing board and rethink it. And so then they had this whole new RFC with the use server and use client directives. So some see Vercel's involvement as an inside advantage, but the reality is that the partnership is crucial for RSC development. No internal test can fully anticipate actual production challenges. And like it's true. Like it's a shame that the users have to be the ones to find out all the issues with the problems, but this is really the only way to test this groundbreaking, weird new stuff. Unfortunately, the users end up being the guinea pigs to a certain extent, to quote Can't See Dogs, but or the canaries dying in the coal mines. And so Over here, let's talk about these early adoption risks, like with Shopify's Hydrogen. You heard Dan Abramov talking about it. The team initially adopted and then abandoned RSC because the complexity and server client abstraction was too much. And the Next.js team have faced a lot of complaints about the dev server performance. And so they had this Brandon Bayer tweet, which was, "This is a desperate plea for extra engineers to work full time on the dev server perf until this is fixed. Sincerely, the global Next.js community." And this is still so bad. My whole team is chewing on nails trying to build a Next.js. And he was being a little hyperbolic, but he's not alone. Like, here's this, the app router is not production ready yet, which had 228 upvotes, and that was in like June or July. And talking about how Hydrogen gave up on it and they bought Remix. And so let's talk a little bit about Remix. So the Shopify team dropped React Server Components and they purchased Remix. The VP of engineering at Shopify said, "To that end, Remix will tackle challenges that developers building on Hydrogen have encountered around data loading, routing, and error handling. One of the biggest bets we made with Hydrogen was on RSC, and while we believe in the technology in the long term, moving to Remix's data loading pattern instead of server components will lead to a faster performance and a simpler developer experience. Changes are coming in 2.0, but 90% of developers' code will remain the same." And 2.0 did come out, and it was very familiar to both Hydrogen before and Remix now. So Shopify considered Remix to be the best alternative to React Server Components at the time. And Ryan Florence had in fact had this article on December 6, 2021, where he talked all about React Server Components and why they were not using them in Remix. And the problem was, at the time, there were no server actions. So every time there was a mutation on the client side, you had to download all of the templates all over again. So since this time, server actions have been added to React Server Components, and it seems like Ryan Florence is coming around to them. In May, he presented this Lighthouse score talking about the latest Remix and React Server Components proof of concept. So Ryan Florence announced on the Syntax podcast that a future version of Remix would be based on React Server Components, and Deanne Almar, the VP of engineering here, always said that they believed in React Server Components. Jacob Eby is a member of the Remix team, and he's been gradually iterating on all of these little demos for React Server Components. One of the first people to really make a simple demo that really helped me understand it. We'll be digging into some of his demos later on. He's really done a lot of great work in terms of demystifying this stuff. And then I do also should mention that Redwood.js has recently announced that their future Bighorn epoch would be a full adoption of React Server Components. So slowly but surely, more frameworks are getting into the mix. It's a gradual learning process as more frameworks try to adopt React Server Components. And Ryan Florence had this really fantastic quote where he said, "A lot of people think it's about data loading. That's just a minor piece of it. Remix is all about levers, on letting you move code to the server and keep it out of the browser so that you have better performance. And RSC is just another one of those levers that let us move even more stuff over to the server that you don't actually need. You're making a network call for JSON anyway. Like, just get the elements. You don't need the templates in the browser." And that was Ryan Florence on Supper Club of Syntax. But here in the conclusion, let's just have a quick look ahead to what we're going to be doing in the next 14 videos. So, with these future chapters, we are here with the introduction and background. Our next chapter is going to be a kind of a deep history chapter where we go all the way back to the first web browsers in a history of asynchronous JavaScript that we're calling Reviving Thenables. And so these JS chapters, these are going to be all about the web platform. We're going to be learning about all of these critical things that React is using to make React Server Components as performant as possible. We have as good of a UX as possible, but there's a lot of stuff that goes behind it. And so originally I didn't want to have these chapters where I didn't talk about React Server Components that much, but the thing is, I kept having to have these little sidetrack little pieces where I explained stuff about about promises, and I explain stuff about streaming. And so that's chapter 3. Chunks is just about the history of streaming in JavaScript. And by itself, it's like 9,000, 10,000 words. It's like they had to be their own chapters because it was too much of a distraction from the actual React Server Components content. And so that's the thing. Once we move into chapter 4, chapter 5, flight request and flight response, these are going to be exclusively talking about the React code. We're going to be doing a deep dive into the React code where we actually look at how each of these things work. And because we'll have all of this prior discussion of how the web platform works, we'll be able to have just like quick links back to the parts where I talk about how these things work. So I won't be distracted by trying to explain how streaming and promises work while I also try to tell you how React Server Components work. So it's going to be a gradual progression. The chapters 4, 5, and 6 are all about streaming, but we're not even really going to get into client components. We're just going to do streaming server components. And then we're going to have to do a little bit more JavaScript lessons, a little bit more about the web platform to fully understand the way that client components and server actions work. So chapter 7 and 8, we'll be learning a little bit more about JavaScript. Then we'll get back into the code and finish learning about how React Server Components work. But look, there's still 5 more chapters after that. And what we're going to be doing is looking at implementations. So that's the thing. It's not just going to be a discussion about how they work. The first 2/3 are going to be exclusively devoted to talking about how they work. And then we're going to show ways that they work. We're going to show it actually working so that you won't just have these abstract concepts. You'll be able to see all the ways that people have put this code to work. And so chapter 11 is just going to be some simple demos, but then we're going to move into the most complex things that people have that aren't Next.js, basically, which is stuff like Waku from Daishikato and like vite-rsc from Nikhil Seraph and like vinxi from him as well. And we're going to talk about all kinds of stuff like that. Ben Holmes and Jacob Eby are the main people behind the chapter 11 demos that we'll be discussing. But there's a lot of other stuff. We're going to talk about like Tangle from Lubiowose, probably pronouncing that wrong, and all kinds of other cool stuff before we get into chapter 13, which is Next.js, which is it's really complicated. It's really hard. There's a reason it's near the end. It's tough. But once we do that, once we understand Next.js as best as we can, we'll be able to build our own basic framework before concluding the series. And so they're going to go into all of these JavaScript and web platform fundamentals, promises, streams, JSON replacers and revivers, the idea of context in both JavaScript and in React, scope, closures, proxies, vis, call blind apply, prototypal inheritance, module systems, bundling, and even more somehow. And this is the reason why we have to have dedicated JavaScript chapters, because you have to understand all of this to understand how React Server Components work. You have to. There's just no buts about it. I can't explain the code unless you understand how these things work. And so there's going to be a lot of demos to help you understand this stuff. Like there's over 100 demos at this point. I was at like 130, I think. It's ridiculous. So I go into all of these different concepts, and you can see like, like over here we have the React code. We have like this is like the browser event loop. Oh no, that's the Node.js event loop. I mean, I go through all kinds of different stuff and I actually explain how it works. You can see the code. These are all on StackBlitz, so you can just go in and edit the code and see the results in real time, fork it, do whatever you want. The code all works. It explains what we're talking about. I spent so much time doing this stuff. It's crazy. And so let's keep moving forward. We're going to be digging through the React code, so line by line, function by function, explaining every part as we go. And so this is actually, as you can see, like if it's a bunch of related functions, I'll put them together in a demo where you can click through and see each part. And then underneath here, I have full explanations of what's happening with that. And so that's the idea. It's that you can see each part of the code. And these are all in different places in the code base, throughout one 3,000 line file probably. And I go through and I put it together in a place where you can click through them, and then I explain them underneath. and then we are going to build our own framework. Don't get your hopes up. It's going to be very simple. We're just going to be applying all these concepts that we learned. We're going to be building it as we go. So like our little demos are gradually going to come together into this framework that all works together. It's a lot of work. I'm still figuring it out. I'm not smart enough. Go contribute to Waku or vite-rsc if you want a real framework. That's the thing. Like there's people doing real work out there that I think is worth other people building on. All of the stuff that I'm going to be doing is just educational. So don't expect this to be something that you can deploy to production, okay? But the idea is that like you're going to see how it works by doing it. There's no better way to learn. And so we're going to build our own React Server Components framework. While we teach, we learn. Seneca the Younger, maybe he said that. We don't know. All right, folks. Bye until next time. Thank you so much, and I really appreciate you guys. I'm going to try my best to do one video a week. I'll probably take a little break around Christmas, maybe even Thanksgiving, but I'm going to do my best to have this done by around February is the game plan. So I hope that you join me for the ride, and yeah, just let me know what you think in the comments below. I'll see you next week as we take a journey through the history of the web platform.